So tonight, I want to cover a couple of bases here. Last week, we spoke about chi-square, odds ratio, and relative risk. That was a kind of statistical test that we used when we were dealing with categorical variables. For instance, if we were dealing with a certain exposure that was either either exposed or not exposed, so for instance, maybe someone who was exposed, someone who used IV drugs versus someone who didn't use IV drugs. And the outcome that we're interested in examining is whether or not they were HIV positive. So we have two variables: IV drug status, which means yes, they use them, or no, they don't use them, and whether or not they're HIV positive or not, which is either positive or negative. Again, two values. Those are called dichotomous variables. They're categorical variables, but as it happens, they only have two values. So when they have two values, what we can do is we can arrange them into a contingency table. And we'll get into this a little bit more if we get a little bit of time tonight, or you can go back and look at the videos from last week. But we can organize them into contingency tables. And using the contingency table, we can look at the rate at which IV drug users are HIV positive versus the rate at which non-IV drug users are positive, and see if we can identify or prove that there's a difference. In other words, that there's an association between IV drug use and whether or not someone in that population is HIV positive. Okay, so there's a few tests we can use to determine that. One of them is called chi-square, and in chi-square, we would take our table, which is the 2x2 table, where the top left corner table is people who are HIV, who use IV drugs and who are HIV positive, and compare it to another table, where we're presuming that there's no difference between the rate of being the rate at which the groups are HIV positive, whether or not they're drug users or not drug users. And we construct something called an expected values table. We compare those two tables, to see how big the differences would be between our expected values if there were no association between IV drug use and having HIV, or what we actually observed in the population. And from that, we can calculate a chi-square value for that statistic, compare it to where we can get critical values, to a chart where we can get critical value, to see if the difference between observed values or expected values would occur less than 5% of the time if there was no association between those two tables. In other words, our null hypothesis, that there's no association, versus our alternative, that there's an association. We can also calculate odds ratios for those two groups. In other words, we could determine, and relative risk, we could determine how much more likely it is to be positive if you're a user versus if you're not HIV positive as a drug user. Okay, so that's two or three different statistical methods that we can use to examine that particular kind of variable. The weeks before that, we were comparing means of different groups. In other words, the mean of versus some group that we already know the mean of. In other words, if we knew that the average average pressure in North Carolina, because they do a statewide health survey, is and they do a statewide health survey, mean pressure in New York is the same as the mean blood pressure for people in North Carolina. Well, we might want to say to ourselves, well, we can't afford, or we don't have the resources to test everybody in New York State. So we're going to do a sample of 500 people or 100 people in New York State, random sample. We're going to take the mean of that sample, compare it to the known population mean in North Carolina, and we do a t-test, right? We compare two means, the means of two groups to one another. Since we know what the mean is for North Carolina, but we only know what the mean of the sample is in New York, that's called a single sample t-test. It's one sample versus a known mean. Most of the time, we don't know either one. We don't know either population. So one of the ways I would determine whether or not there's a difference in the mean blood pressure for North Carolinians versus New Yorkers is I would take a sample of 100 random people in New York State, compare it to 100 random people in North Carolina, and do a t-test, right? And that t-test would compare the means of those two populations. Again, if the differences are far, if the two means are far enough apart, given the variability of the data, then we could reject the null hypothesis that the two means are equal and accept the alternative that they're not equal. And that would be a t-test. And the form of that t-test would be not a single sample t-test, two sample t-tests, because each of the two populations are represented by samples. We don't know either real population mean. The third kind of t-test that we might do is when we are, say, testing a drug, for instance, and we want to know whether or not it lowers blood pressure. So instead of having two groups, one group we give the drug to, another group we give the placebo to, and measure their blood pressure after 2 weeks of being either on the drug or the placebo. Well, if we take two random sets of people from two different groups, well, they might start out with the people in the placebo group have a lower average blood pressure than the people in the drug group, or vice versa. It might be average blood pressure in the people in the sample from the drug group is lower than the other group, right? So to eliminate, and there might be more smokers in one group than another. There might be more, the average BMI for one group might be higher than another. There's a lot of compounding factors that could be in there. To eliminate those, one of the things that we might consider doing is that instead of examining the difference between group A and group B, we would give the drug and the placebo to each subject. And we would determine what that person's blood pressure was when he was on the drug for 2 weeks and when he was on the placebo for 2 weeks, without them knowing which one that they're on. So we would get two readings, one when the person was on the drug, and the other when the person was on the placebo. And we would be interested in then, that's called a paired sample t-test. In other words, each measurement is from the same person. And we don't have to worry about whether or not he's a smoker in the drug group or in the placebo group, because if he's a smoker, he's a smoker in both groups. Takes that variable out. So we would examine the differences between those two rather than the actual number. That's called a paired sample t-test, and we would look to see if there's a difference in if the differences, average difference between those two values is equal to 0, or if it's different than 0. If null hypothesis is that there's no difference between the placebo and the drug blood pressure for the placebo and the drug, then we would expect the average difference for all of these people to be 0, to be no difference depending on based on which one they were taking. Okay, and we would look to see if there is indeed our result is truly different than 0, or if it's not, and that's called a paired sample t-test. Then on occasion, we'll take a look at what we looked at in the intervening week before Chisquare, which is analysis of variance, where we again are looking at the difference in the means of groups, except this time, unlike the t-test, we're only comparing two groups. Now we're looking at the means, differences in the means of 2, of 3, 4, 5, any number of groups that we want to compare. And we would do an analysis for analysis of variance to determine whether there is, whether on null hypothesis that there's no difference between the means in any of the groups, or alternative hypothesis that at least 2 of the groups are different, means that 2 of the groups are different. We would do an analysis of variance to determine whether there's a difference there. Okay, the big difference here is we're working with multi-group groups, not just those 2. And if we find that we can reject the null hypothesis, that there is a difference between at least 2 of the means, then we go and do additional tests called post hoc tests to determine which of the means are different. It's not going to be all, doesn't have to be necessarily all of them. Could be only 2 of them, could be 3 of them, and so on and so forth. But then we would do that test. And again, so that's what we've covered in the last few weeks. That's mostly going to be what's going to be on the test that we're going to cover on those different kinds of tests. Okay, and I'll put some material up. Maybe it'll be good for some review as well. Okay, so what's the long and short of all this? The long and short of all this is, let's see if I can, let's find out what, whiteboard. Let me just find, so I can't find my, that's not showing up here. Awful lot of junk on here. Already. Well, I transferred a lot of stuff from my old machine. Yeah. Yeah, already is right. Can't find my OneDrive. Yeah, okay, I'm gonna get this out of the way. I'll do this way. Okay, let's get rid of that. Uh-oh. Went dark here. See, we stand still too long, it gets dark in this place. That's not going on. Stand up in the back there, wave around a little. Thanks a lot. There you go. Okay. Okay. Let me get rid of this. I get a little bit more writing space here. There we go. Good. Okay. So long and short of this is that our long and short of this is that our, did I change that there? No. Is that our analysis, whoops, what did I do now? Long and short of this is that our analysis is based on the kind of data that we're working with. Okay, so everything starts with the data. The set data that we collect is the same thing. That's why we were just, before we got online, that's why we were discussing that when you go to work on a project or your capstone and so on and so forth, it's important before you start collecting your data that you think about, well, what kind of data am I collecting, and how am I going to analyze this data when I'm done? So you don't want to collect the data and not worry about what you're going to do with it when you're done. You want to first decide, when I'm done with this, how am I going to analyze this data? What am I going to look for? What am I looking to prove? What data help me do that? And what statistical tests am I going to wind up doing? That may influence your, for instance, in a survey, it may influence what kind of data what kind of questions you ask, what kind of data you collect, what kind of questions you ask, how you ask the questions, how you store the data, what categories you ask about, and so on and so forth. When you do measurements, it may determine what kind of measurements you take, what kind of measurements you don't bother taking, and so on. So you want to really take a look at how you're going to analyze the information that you're collecting at the beginning rather than at the end of the whole process. So as we said, if you have a nominal variable and a numerical variable, right? Numerical variable is scalar numerical variable. A numerical variable is, as SPSS calls it, what do they call it in SPSS? Category. They have nominal, ordinal, and scalar. Called a scalar variable in SPSS. Scalar. Okay. Well, when you deal with that kind of information, scalar information, you're usually looking for the mean and the variability, like the standard deviation. When you're dealing with a nominal variable, well, a nominal variable is a category or a name, right? So that's categorical. So that generally in nominal variables, you might have a couple of values that it might have. You might have many values. So for instance, if the nominal variable is gender, right, it might have two values. If you're just looking at male and female, it might if you're looking at ethnicity, right, it might have. See if my audio comes back. My audio should be back now.
So I'm gonna get the help.
Okay. Does it say I'm back?
Go down and get the help desk?
No, it's okay. I think it's restored now. Did it go away?
Yes. They said
Okay.
yes.
Okay, good. Yeah, but that nasty message is still there. So we can't get rid of that. Okay, is it clear screen now?
Yes.
Okay, good. All right, sorry about that. It is maddening though. Okay, so at any rate, getting back to this. So male and female, I might be interested, for instance, if my numerical variable is BMI, right? That's a number. We find an average of that. I might be looking for a population to determine whether the BMI for males, the average BMI, the mu average BMI is different or equal to the average BMI for males.
Why would that be nominal?
Right. The gender is nominal, male and female, right? But we're comparing the average. In other words, we're always using two variables when we do a test, right? So we're comparing the average BMI for males and for females. Male and female is a nominal variable. The BMI itself is a numerical variable. So we're comparing the average BMI, the average numerical variable for males and for females. For ethnicities, we would do it for multiple groups, for 4 or 5 groups and so on. So for that kind of situation, we use a t-test. And again, it could be any of those numbers, a different number of t-tests, could be a single sample t-test, 2 sample t-tests, paired sample t-tests. Now, if I'm doing it for ethnicity, well, then it's going to be more than 2 groups. My groups are maybe white, black, Hispanic, Asian, so on, other. There might be 5 groups. But again, I'm looking for the mean BMI for this group is equal to the mean BMI for this group is equal to mean BMI for this group is equal to mean BMI. So in other words, I'm still looking for averages because it's a nominal and a numerical variable. In that case, we use analysis of variance, right? And then finally, this most recent week, we looked at situations where we were working with categorical variables. So for instance, I mentioned before, nominal categorical variables. Instead of gender and BMI, we might be looking at gender and HIV status, right? Both of those are nominal variables. Gender is male or female. HIV status is positive or negative, right? HIV positive or HIV negative. So in that case, we would set up a contingency table where we have gender, male and female, and we have HIV status, positive or negative, And we would be comparing these two nominal variables, both nominal. So no averages involved. We're not taking averages because they're nominal variables. It wouldn't make any sense. Average doesn't make any sense for them. So we would be trying to analyze whether or not there's an association between gender and whether or not person is HIV positive or not. So again, this is specific. We're using Chi-square for this analysis. We also, if it's a 2x2 table, we're using odds ratio and relative risk as well. But we're using these specific tests for this specific data set. Okay, so now that's great for what we've done so far. So what have I not spoken about so far? What kind of variables have I not spoken about? I've spoken about nominal versus nominal, nominal versus numerical, right? Well, yeah, ordinal special case. Ordinal is a special case. You may have heard the expression parametric statistics. That's what we're working on now. Ordinal is kind of a special kind of thing that's really kind of non-parametric statistics. But you know, before the end of the semester, we'll talk about that just a little bit. So we got nominal versus scalar, nominal versus nominal. Let's see. Let's see. Nominal, 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 scalar. How about scalar versus scalar? Or in other words, numerical variables versus numerical variables. Well, we haven't talked about that at all, have we? Is there an association between one numerical variable and another numerical variable? So for instance, is there an association between a person's BMI and their blood pressure? Both of those are numbers, right? So I could find the average BMI and the average blood pressure, but they're not differentiated into different groups. So in that case, I need to examine whether this numerical variable has an association with another numerical variable. So one of the ways that we do that is that we will graph. So for instance, if this is BMI and this might be blood pressure, I might make a little dot here for each person where their BMI and their blood pressure is. So let's say that this is 20, 30, 40, right? So a person BMI is 25 and his blood pressure is, say, 80, dot will go there. Well, if his BMI is 30 and his blood pressure is 110, that would go there, and so on and so forth. And what we'd be looking for is to see if there's an association between BMI, numerical variable, and blood pressure in the form of as one goes higher, the other goes higher too. Or as one goes higher, the other goes lower, right? And these kinds of associations are called correlations, right? After we come back after Thanksgiving, we are going to talk about correlations, about situations where we're looking at numerical association between numerical variables. When the line goes up, as BMI goes up, blood pressure goes up. That's called a positive correlation. If it goes down, in other words, if BMI goes up and it turns out the blood pressure goes down, that's called a negative correlation. And the slope of the line tells us whether it's positive or negative, right? This is a best fit line for all of those points. In other words, a line that kind of is kind of best fits the points that we plotted. Okay, there's another element to this where we can actually take a look at the elements of that line, see what the formula of that line is, and we can create a formula which tells us that a formula for that line, which tells us the relationship between the two of these, and that's called regression. Okay, the word regression really has nothing much to do with what we're doing. It comes from the original person in studies that developed this, where this was developed, and we'll talk about where the word actually comes from. But that regression is nice because now not only do we see if there's a correlation between the two items, but we also see based on the slope and various other factors how strong that correlation is and how significant it is. In other words, how much of a BMI change will cause how much of a blood pressure change. The slope of the line will give us a lot of information about that. Really powerful test. We'll learn about that next week. Sometimes we can even take a numerical variable, like particularly a dichotomous categorical variable, like for instance, a heart attack. Probability of having a heart attack versus the person's blood pressure. So maybe we can look at people who had heart attacks and what their blood pressure was, and maybe we can combine this numerical variable in such a way that we can figure out what the probability is of having a heart attack based on what your blood pressure is, maybe plus what your BMI is, and so on and so forth. This kind of analysis where you're looking at how these different other variables associate a probability, right? That's called logistic regression. We're not going to be tested on that. I'm not going to give you homework on that, but I want to at least introduce that to you. It's a little bit of an advanced topic, but I want to at least introduce it to you so that if you come across it, or if at some point you really need to work with it, that you'll at least have some tools to know what it is and what it's about. Okay, so
the shape of the line is regression.
The direction of the how close those points are to a straight line is correlation.
Yes.
Okay. Whether the line goes up or down makes it a positive correlation or a negative correlation, right? The formula of the line, right, is a regression. Okay, so the formula of the line, for instance, if the line is blood pressure is equal to, let me think about the best good way to do this. Blood pressure is equal to 2 BMI plus 17. That's a straight line, right? That would be, a slope of 2 BMI. Well, that slope tells you that for every increase of 1 in the BMI, you have an increase of 2 in blood pressure. Right, so that slope tells you the relationship between the two of them.
Like X and Y.
Yeah, it is X and Y, but the X and Y is BMI and blood pressure. We'll talk when we get to it. You'll see instead of X and Y, we'll use the actual variables. But yeah, it's exactly right. So it's the formula of a straight line. So we'll be taking a look at that as well. So let's talk about what's coming up for us now. So we have scheduled for ourselves. We have an exam, right? And so let me just go to, yes, we do. Yes, we do. Okay, next few weeks. Okay, so I played around with the schedule a little bit. I know that drives people crazy, but I do it because I have your interests in mind, and I want to make this as cohesive as possible without making too many left turns and stuff. In the original syllabus that we've used, that we used last semester, we did analysis of variance after chi-square. But analysis of variance is really comparing means. It makes more sense to do that with the t-test than after chi-square. So that's kind of the way I wanted to do that. But okay, so this week we're kind of examining this material that's going to be on exam 2. And next week I will be posting the exam. Okay, so now the exam will be online. Okay, similar to the first exam, you'll have 2 attempts, so on and so forth. Your score is going to be average of the 2 attempts. And I'll go through all the details of it and so on and so forth. It will be due on our next class is December 2nd. So I will make it due. I really need to update the syllabus too. So you'll see some of the changes I made here when I go to it. Don't be too angry with me. Okay. Again, I'm trying to do this. Okay. So normally we would have had the exam tonight, right? So, and actually, so I'm doing I'm going to post the exam. So by the middle of the week, the exam will be, by the middle of next week, the exam will be available. We have no class on the 28th. And I will make the exam due after the holiday, probably, probably on December 1st. So you will have more than a week to do the exam. But it will be due on Sunday night before our class. And then when we come back on this, is that right, December 5th? Yeah, our class is December 5th. I might even be able to extend it maybe a little bit further into the week there. Give you even a little bit more time if you want to do it, if you need it. But certainly a couple of days before our class. December 5th, we will move on to correlation and regression and to multiple and linear regression. Okay, those are going to be our last two topics. I'm also going to work in here sample size and power, which we really only gave very short shrift to in one of the lecture videos earlier in the semester. But we really need to pay a little bit of attention to it, because as you guys work on your capstones, one of the first things you're going to have to do when you start to imagine how are you going to put together your capstone, what data you're going to work with, is what's your sample size have to be. Do I need to take 100 surveys or 1,000 surveys to prove what I want to prove? So sample size is an important topic. So we're gonna hit that after the exam, after this coming exam. So starting next week, early middle next week, I will make the exam available online, and you will have until December 3rd at least, end of day December 3rd, to complete the exam. Complete your 2 attempts on the exam. There'll be, as usual, there'll be a section on the discussions forum where if you have questions, need clarifications, and so on and so forth, you can post your questions there so that if I give you a response, everybody will be able to see the same response. You can also check it for corrections or qualifications or something like that to do with the exam as well. So keep your eye open for that kind of stuff. Okay, and then you'll notice here it says something about final project option or exam 3. So we have a little bit of a hangover there with some extra stuff, the sample size, correlation, regression, and so on, and then that we haven't covered in any exams. So at the end of the semester, December 17th, you have the option of either doing a third exam. Won't be very extensive. It's only going to have that last, again, non-cumulative, so only have a couple of weeks worth of material on it, or doing a modest project. Now, what do I mean by a modest? A lot of people tell you it's only a modest project, and it turns into a beast, right? So you want to know what a modest project means. What the hell does that mean, modest project? Okay, so let's take a look. Okay. Let me just get this here. Okay. Okay, so what am I asking you to do? I am going to give you a whole series of databases. In fact, here you go. Here's a whole bunch of New York City Community Health Survey data. Look, there's a couple of SAV files here. New York City Youth Risk Behavior Survey, Framingham study. That's the one that has to do with heart disease and smoking with doctors. Digitalis survey study, physical activity and transit survey, other eye color, flicker frequency survey, hair color versus pain threshold, all sorts of interesting data sets here. Okay, you can use any of these data sets if you want, or you can instead let me know if you have some other data set you want to work with, perhaps one from another class, perhaps one that you're working on at work or something like that, and use that data set instead. Okay, now the one of the major data sets that's in here, this first one, is the New York City Community Health Survey. How many of you guys know what that is? Have you ever heard of that?
There's a video on it.
There's on here.
Yeah.
Yeah. I mean, before that.
Guest speaker.
Yeah. Have you heard of it before? No. Okay. Actually, she mostly covers the version of it where you can do these quick online kind of combinations of a couple, just two variables or something like that. Well, this data is a little bit more. Today's session is mostly review, right? So we're not. So in other words, we're not going to ask you about correlation regression. I just brought that up kind of as a preview of what we're going to be working on later on. Okay, so let's talk about this New York City Community Health Survey. Have you guys, anybody online, heard of it before? I'm going to give you an idea what it looks like. Happens to be a pretty healthy survey for us. New York City Community Health Survey. I think I can get to it just like that. And here we go. Okay, Community Health Data Survey. So every year, once a year, New York City does a random survey of 8,000 people in New York City. I think it's primarily a phone survey. They asked these 8,000 people a series of questions, up to about 150 questions. Actually, don't really, in other words, in certain things, if you're not a smoker and you say you're not a smoker, then there's questions they don't ask you, like how much you smoke, when do you smoke, that kind of stuff. So nobody really answers 150 questions, but they answer a lot of questions. Okay, that survey is done every year. We have data based on that survey every year for at least the last 10 or 15 years. And in fact, if I go in here and I go down to here, these are the data files, the actual fraud data from each one of those different surveys. The most recent one that they've put online is 2018. I actually have a couple for you that have already been downloaded and converted, 2013, 2016, something like that. Let's take a look at 2018. So what do we have here in the 2018? Well, one thing we have is a copy of the questionnaire that they actually used. This is actually the questionnaire. And it's really instructions to the interviewer on how to conduct a survey. And if you were doing a study with a survey, you would want to do this because you would want to say, have you with a person that's going to do it? What's that?
Instead of your audio is lost again.
Ah. Oh, no, I have. I think it's okay here. I see it online here. Does it still say that?
It's working fine.
Okay, yeah, I think so. Maybe it might be somebody else's audio. Let me make sure everybody's muted on the other end here, so we don't get too much background noise. Okay. Okay, so if you were going to do a survey, right, you would want to write this out very specifically because let's say you're getting help. Not only, first of all, number one, 8,000. They're not going to hire one guy to call 8,000 people, over the course of a month. They're going to hire a boiler room of people to make these calls and do these surveys. So they don't want one person asking a question one way and another person asking it differently. They want to be as uniform as possible. So this is scripted. It's very strictly scripted. Hello, my name is blank. I'm calling on behalf of the City Department of Health for click, right? Now, my guess is that they get 8,000 people to respond to the survey. They probably called 30,000 people. That's why they need a boiler room full of people. Because I don't know about you, I never answer my landline anymore. Anyway, I can't answer my landline anymore, right? I get calls from Hunter, Polytechnic, whatever, any school I've been involved in, Rutgers, any school I've been had any involvement in over the last 40 years calls me up for a contribution, right? That's them. And then, we give to a lot of different small charities at the end of each year. So, and, like everything from Planned Parenthood to this, to that, to animal things and so on and so forth. I swear to God, I'm no exaggeration. Right now at home, I have a stack of at least 20 calendars for 2020. Because half of these organizations, they say, because we don't give them a fortune. We gave them, $50 or something like that. But we give to a lot of them. And each one of them sends us a freaking calendar. So I literally have a stack of 15 or 20 calendars sitting at home right now for 2020. So at any rate, thanks for the calendars anyway. Okay, some of them I like, some of them are really pretty. But at any rate, but yeah, you can imagine not everybody responds to this stuff. Like I can't take calls anymore. We just, when they get me on the phone, I tell them to email me or send me something in the mail. Yeah, and you can't get them to stop. It's unbearable. So at any rate, and Hunter, I give money to Hunter, but then they keep calling anyway. So at any rate, yeah, they know me. What's that?
Is it only landlines like this?
Yeah. Oh, they don't call. I don't get any calls on my cell phone. But I never, I'm sure there's plenty. Yeah, I get things from North Carolina Police Department, which I'm sure is a scam. And there's a, I don't know what they do. They had fundraising things too. A lot of them are things where like they convince these organizations that, we'll do this fundraiser for you. And then they take 3/4 of the money and the organization gets a quarter of the money, but they don't care about that because they needed the quarter of the money, so they're willing to do that. But I mean, it's not a very efficient way to contribute money.
But the survey is only people who have landlines from the phone book.
I think they do landline. Yeah, skip the cell introduction if cell. No, there's a cell version. There is a cell version. I don't know how to get the cell phones. I get very few calls on my cell phone, right? Like this. I get some. It's not like none, but I don't know exactly how to get cell. Landline's much easier. Hello, my name is, and this is the landline version. If you're calling to a cell, if you're calling a cell line, it's a different script. Okay. If you qualify for the research, we will give you $10 as a thank you. Hey, there you go. Now I know why 8,000 people answer this, right? Right. It's a long survey. If they trust me, if they knew how long the survey was, they notice it doesn't say this is 150 questions. It just says you're going to get $10. And I guess once you're halfway through, there's no going back. You know, you want that $10 at that stage. So at any rate, I'm off on a tangent here. Okay, let's see if I got any comments online. Anybody ever been called? Anybody ever been called by these guys, by Department of Health for a survey like this? I mean, you would think, well, yeah, all the time. Okay, all right. So at any rate, so this is reasons to call back, reasons not to call back. If it's busy, no answer, they set up and they call them again. If they call them and somebody picks up and claims they don't speak English, they call back with a Spanish. They give them a Spanish interview to call. If it's a fax, obviously there's a reason why you don't call back. And then the various questions that are in here are scripted. For instance, let me go down to the actual questions themselves when they finally start to get through to these things. Question number one, would you say that in general your health is excellent, very good, good or fair or poor? What kind of variable is that? Bingo, category. It's a nominal variable that's categories, right? There's order to it, so it's ordinal. It's an ordinal variable, right? Okay. Do you have any kind of health insurance, including private health insurance, government plans, or Medicaid? Yes, no, don't know, don't use, refused. What kind of variable is that? Yes or no? Yeah, because if you ignore the other ones, it's dichotomous, but it's nominal, right? It's nominal variable. It's a yes or a no, right? So it's a dichotomous nominal variable, right? And so on and so forth, right? If the respondent says, so in other words, if you say you have health insurance, they then ask you, well, what kind do you have, right? And then all of a sudden this is a nominal variable, but it's got many values. It's not dichotomous, right? Could be Medicare, Medicaid, a COBRA, so on and so forth, right? So that is the nominal variable. And there are numerical variables in here as well. Not many. It's largely nominal variables. Mental health. Over the last 2 weeks, how often you've been bothered by the following problems? A little interest at it done. Not at all. Several days. More than half days. Nearly every day, and so on. Again, categories, right? But ordinal. Not at all. And so on and so forth. And let me just see. How about age? I know they ask age. Whoops.
It says, are you over 18?
Yeah, I'm looking for an actual age variable. I'm not gonna, there's so many AGEs here that I'm not gonna. Actually, I'll look at the data rather. Oh, here we go. What is your age, right? So that's a numerical variable, right? So they ask them what their age is, right? And then they also categorize their age. So they collect it both as a numerical variable and as a categorical variable, right? So it's a gender. Okay, how do you describe yourself? Man, woman, gender. This is a nominal variable, right? It's not categorical, right? Just different groups, different possible stuff, but it's nominal variable. Okay, so these are all of the different questions that they ask. Now, what else do we have here? Where did I put it? Here we go. Where'd it go? I must have closed it. Go back here. Okay, 2018. Okay, so now What about, let's summarize all this. Let's look at when they put this information in. If you say that I am male, they don't type in MALE. They put in a number 1, female 2, transgender 3, and so on and so forth, right? They put in numbers. In order for you to do an analysis later on, you have to keep track of what those numbers mean. And in order to do that, you maintain a code book. And this code book has all of the various groups of variables and what the values represent. So for age, it's a numerical variable. For diabetes, number here. Have you ever been told by a doctor, nurse, or other health professional that you have diabetes? Well, look, the variables that's the variable is diabetes 18. The question is, have you ever been told, etc. Okay, and the actual data that goes into the database is if you say yes, they put it in a 1. If you say no, they put it in a 2. Okay, and so on and so forth. So now that tells you how this data has to be coded. Okay, so now I'm going to go and I am going to go to a data set that we've already downloaded. Full data set. Let me see, I got a few of them here. Okay. I want to get the full one. Yeah, why not? I'll get the full one. I can't help myself. I talk to myself a lot. I can't help myself. Desktop. Okay, I'm going to save this on my desktop. That's from Blackboard. Now you'll notice that on their actual website that I can go in and get the data set itself. But the data set is an SAS file, different program than SPSS. However, you can import SAS files into SPSS. So I just downloaded it. There it is, Community Health Survey 2013.sav. Okay, let's see if that's here. Make sure it's on my desktop. And let me see, I was trying to download this one. Did it download? I thought it did. So and there it is. That's the SAS data set for 2018. So I'm going to put that on my data set on my desktop also. I'm sorry.
You can open SAS.
You can open it up. You can import it into SPSS. So I'm going to do that right now. So I'm going to open SPSS. Hopefully the right version will open if I click down here. It should. Yes, right version opened. And those are on my desktop right now. I have two files on my desktop. The 2013, I believe it is, one that was already converted into SPSS is a .sav file. And I also have the SAV file for 2018 I just collected. Okay, so let's see what will happen here. I am going to say open data, and I'm going to navigate to my desktop, and I'm looking for the Community Health Survey for 2018. I don't see it. Anybody know why I don't see it? Not a .sav file. I got to change that. I got to change that to SAS files. Okay. Yeah, or all files. Either one will work. And there it is, right there. So I'm going to click that and say open. Now it will import that data into SPSS. Every one of those columns and rows, and there they all are. Just the way you would expect them to be, with numbers and maybe a numerical variable every once in a while. Okay, and if I click on the variable view, you can see what all these different variables are. Mood 63, smoke 5, smoke 5A, smoke cat, type of smoker, number of cigarettes smoked, smoker. Here's one: smoke every day versus someday. Smoking status, smoker, and the label is smoking status. But the only problem is that we don't have the values. We don't know what they represent, right? We don't know what smoker, what was represented there. So we have to go to our code book. Right? Remember that code book we were looking at for 2018? Where did I put it? There we go. Let me go back here. I need to go to that code book, and I need to search this code book for, what was it, smoker?
Smoke status.
Smoker. I think it was smoker was a variable name. Have you smoked at least a cigarette? No.
Oh, there's smoker.
Smoker, yes.
Oh, no, that's prior years.
Was there another one? Let's see. I thought there was one for just smoker or non-smoker. Oh, there's actually three categories. Have you smoked at least 100 cigarettes in your entire life? Do you now smoke cigarettes every day? Some days not at all. Yet one never is a non-smoker. Two is a current smoker. Three is a former smoker, meaning you've smoked at least 100 cigarettes, right? Would to make you a former. So this is not dichotomous. This has three values: 1, 2, and 3, right? So 1 is not a smoker. 2 is a current smoker. 3 is a former smoker. Okay. What's that?
You don't know.
Hit to you.
I don't know if I'm a smoker.
I'm just here for the $10. Exactly, yes. Exactly right. Okay, so where did it go? Where did my SPSS file go?
So that's because it doesn't transpose in SPSS. The data isn't there.
No, yeah, if you open an SAS, the formatting will be there. If you open an SPSS, it won't transfer the formatting.
So you have to.
So yes, you have to enter it. You have to look it up in the code book. But now remember, see all these different questions we have here? There's questions in there about what your diet is like, how many sugary drinks you drink a day, how many, whether or not you've ever been diagnosed with asthma, yes or no, whether or not you have been diagnosed with diabetes, so on and so forth. So you might be interested in examining whether people who drink sugary drinks, a lot of sugary drinks, are likely to be diabetic. Is there an association between drinking a lot of sugary drinks and being diabetic, or between eating a lot of um, servings of fruit and vegetables and being diabetic? You don't need 150 variables for that. You only need two variables. That is, so if you're interested in examining smoking and whether or not these smokers are insured, if smokers have insurance, or whether there's an association between being a smoker and not having insurance or something like that, you'd only need those two variables: insurance, yes or no, and what your smoking status is. So 1 was a current smoker. 2 was a, don't remember. No, one was a non-smoker. One was what?
Everyday smoker.
Okay, current smoker. 2 was what?
Wasn't it former smoker?
Never smoker. I don't remember. I have no. Oh, it's right behind here. Right. 2 was current. 1 net woman's never, 2 current, and 3 former. Okay. Yeah, that's kind of counterintuitive. Okay, so I need to change that. 1, never. 2, current. Maybe I'm only interested in that. Maybe I'm just interested in that. Maybe I want to make this a dichotomous variable. I'm only going to look at current smokers and non-smokers. Or maybe I'll combine them later on. Okay, and I'm going to say, okay, so now if I go back to my data view, now when I look for smokers, if I go up here to view and turn on value labels, which it is, if I scroll over to the 50th column, did I pass it already? Oops. Why is that coming over here? What? Oh, BMI. Look at weight. They ask them for their weight and height, I guess, because they wind up calculating BMI. We have a numerical variable. So if we wanted to know whether smokers or non-smokers have higher BMI, we would use what kind of test? It's a dichotomous categorical variable, smoker, non-smoker, and the other variable is numeric, t-test, right? We're comparing the means of the two groups, smokers versus non-smoker. So we use a t-test, right? Okay, so now let me see if I can't find. Yeah, I should be able to see it here somewhere. Man, I missed it completely.
Oh, it has a number on the top.
It has a variable name on the top, but it doesn't have the column. Doesn't have which column. Yeah. So easy to scroll past it. The variable labels are turned on, so we should see it. Let me just do it a little bit more carefully,
Are you able to search?
just to make this point. Yeah, I could also do this. I don't want to do that. I want to find data. Okay, sort variables by name. Okay. So now they're alphabetical. I sorted the variables by name. So now they're alphabetical. So I should go over to the S's. Smoke 5. Smoke 5. Smoker. Oh, it's in R. That's why it's passed here. Here we go. There it is right there. Right? So this is so if you look, it substituted the word smoker and not exactly for 1 and 2. If I go up here to view and turn off the value labels, it goes back to just the numbers. Okay, now I did this quickly, so I ignored what 3 was, like former smoker. I could have created a new variable that combined 2 and 3 into a dichotomous. I could just work with it as 3 variables and do a analysis of variance, for instance, and so on. But I wanted to make it a little simpler for this particular case. Now you say to yourself, boy, this really looks like a pain in the butt I have to go to the code book and I have to code this and so on and so forth. But you really only need the variables you want to work with. So the rest of this stuff, I could just highlight one of these columns, right? Go over to another column and then just say delete, clear all of those. So I could remove all but the variables that I want to work with. So you may only have 2 or 3 variables, right? Instead of having 150, you may have only a handful, 5 variables or something like that. As a matter of fact, one of the databases that I've given you here, I don't want to close it yet. One of the databases that I've given you here says 2013 full and 2013 simplified. I'm going to click on that. I'm going to say save link as, and I'm going to save it on the desktop. Okay, and then I'm going to go back into SPSS. Did I close it? I hope not. There it is. I'm going to go back into SPSS. I'm going to say file, open, data, and I'm going to open that database. Now that's an SAS file, so it should default to SAS, and there it is, 2013 simplified. And what I've done there is I've removed many of the database, many of the variables, and I've only left a few of the variables. So for instance, this first one is age. I left the variable age. I left a variable borough of residence. I've left a variable race or ethnicity. I've left a variable neighborhood poverty based on percentages, whether a person is insured or not, uninsured, type of health insurance. So I've given you a bunch of these. Flu vaccine, whether or not they received a flu vaccine in the last 12 months, what their gender was, whether they were in their nativity, whether they're US born, yes or no, if they had children under 18. So there's a bunch of these. If I look on the data view, the age is numerical. All these others are categorical. So I need to go in and look up what if I want to know borough, I need to go in and find out what each one of those numbers, and then go to the variable view and put in for each of the 5 boroughs what numbers represent, like 1 Manhattan, 2 Brooklyn, 3, and so on and so forth. Right. So
what is missing?
I could identify SPSS if you tell it to find an average for like age, find the average age of this group. If there are people that didn't give you the age, so it's blank, like you may see some blanks in here. I don't want to spend all day. Yeah, there's a couple. I passed a couple, right? There's a couple of blanks. It will ignore them, those missing variables. But sometimes you may be uncomfortable with why they may be missing. So there's a couple of things. You can just tell it to ignore the missing variables, which will just ignore them as if they're not there. Or you, when you categorize that, when you define the variable, you can tell it that you can code this so that if you can give discrete values to the missing values. So you can tell it that if you see a 99, or if you see a 999, or if you see a 9999, those are discrete missing variables. And you can use 99 for when they didn't answer, when they refused, 999 because you forgot to ask. And so if you need to go back and figure out why the data is missing to justify why you didn't include it, then you can also deal with it that way. Or you can just click no missing variables, or not click anything, and it will, or click no missing variables, and it will ignore any missing variables. It won't keep track of them at all. Okay, so you have a couple of choices here. You can go back. I will go back and recode this. So at least this one is available to you. Now, what could you do with this one if you wanted to do a project? Well, what does a project entail? Okay, let's go take a look at what our rules are for this project, what our objectives are. Okay, find a project of statistical methods you learn throughout the semester to a problem of public health. I really, if you feel comfortable doing this, great. I don't want to bend your arm or anything like this. I think this is good because you actually have to think, look at the data, pick a couple of variables, and think to yourself, what do I want to do here? What do I want to prove? Which variables am I going to choose? What test? What's the right test for me to apply? So I like this because it gives you an opportunity to actually apply what you've learned rather than just answer a canned question on an assignment or something like that. So what do we want you to do? We want you to go and we want you to pick out a couple of variables, 2 variables. It could be just 2 variables, could be more than 2 variables. If you want to get a little bit more ambitious, doesn't have to be, right? And we want you to put together a report. This report is in the form of, basically kind of imagine it as being in the form of a poster. How many of you guys here and online have been to somewhere where they had a poster presentation? Right, you go to a conference, they have posters. What does that look like? For you guys online, okay, what does that look like? APHA posters. Oh, here you go. Here we go, right here. There's a whole bunch of pictures. So what's a poster presentation? Well, these are people at the American Public Health Association that presented their research in the form of posters. Now, if you're a big shot and you're doing really important research, they give you a podium and a half hour to stand on the podium and tell everybody in the room, and people come and attend your lecture and tell people about your research, right? If your research is just preliminary, you're just starting it, you want to get some feedback on it and so on and so forth, or it's not the type of research that is going to be of general interest, more specific interest, so you're not likely to fill up a room of people and so on. Well, they have an area where 100 people, 200 people can create these posters that represent their research, what they've been doing, what the problem is they're trying to solve. And they use graphics and statistics to demonstrate some of the stuff that they've been doing. So for instance, if I can get this one to just open in the page, okay, you can see gender norms and sexual behaviors among indigenous people in Peruvian Amazon. Purpose, background, methods. Oh, look, she has her data here. Findings. Look, she got very pretty graphics and stuff like that. So what we want you to do is create a poster. It doesn't have to be this. We're talking about doing something either on Word, PowerPoint, something. I like PowerPoint because it's easy. You can lay it out like with pictures and stuff like that. A lot easier than Word, right? So what we want you to do is basically mimic this. In other words, let's say that you're interested in, with the database that I have here, that you are interested in whether or not people, let me go back to the data, is people that got a flu shot, whether or not people who were native to the United States were more likely than non-natives to receive a flu shot. So what do you got? You got two pieces of categorical data: nativity, yes or no, and receive the flu shot, yes or no. So you only want to work with those two variables. And what are you going to do? You are then going to, let me go back here to the description of the project, which I lost for some reason. Why did it go away? I didn't mean to make it go away. Oh, because I had it open on. No, that's not the reason.
It's on the tab.
Is it? Oh, you could be right. No, it's up here. Yeah. I closed the tab most likely.
Oh,
Here it is. Okay, good. Yeah, I had it open as a PDF file. Somehow I closed it. Okay, so what are we asking you to do? We're asking you to do a report, a poster, 4 to 8 sheets of paper, right? Probably no more than 10, right? And we want you to make it so we don't want you to type tiny little words until you fill up 8 pages. We want to make it so that it's, visible, legible, that's, someone can look at it, hold it in front of them, look at it, and so on and so forth, kind of like it's a poster. And we want you to give us an introduction. Why are you interested in this? What are you trying to demonstrate? Give us some of the descriptive statistics. If I'm looking at nativity and flu shots, I might be interested in what percentage of people are native to the United States in New York City. What percentage of this population has insurance? And so you give us some background on the population using the data that you have. Then tell us what method you're going to use to do the analysis that you were talking about in your introduction, right? In other words, oh, gee, I'm comparing these two variables, and I'm going to use the chi-square analysis. Or since it's a 2 by 2, nativity and yes or no, I got a flu shot, I might do odds ratio and so on and so forth. So I'm going to use these statistical methods, describe the statistical methods. Normally in a poster presentation, you wouldn't like give a formal hypothesis, a null and alternative hypothesis. If you wanted it to do it for this purpose, it'd be okay, right? Like putting a null hypothesis, there's no association between whether that person is born in the United States, not born in the United States, or whether or not they get a flu shot in the last 12 months. The alternative is that, yeah, so for our purposes, maybe you would put a null and alternative hypothesis. Real poster, you wouldn't bother to do that, right? And then put your results. What is the result of your chi-square analysis, your odds ratio? What is your confidence interval for your odds ratio? Okay, and then in discussion, what does that mean? Were you able to prove it? Was it insufficient data? You weren't able to prove it? What is it? And so on and so forth. And I don't see it on here. It's probably on here somewhere, but I would like you to include one or two, it is here, 1 or 2 published papers on the topic. So if you can find it, maybe you can find something about nativity and whether a person gets a flu shot or not. If you can't find that, give us a paper that describes the statistics. Give us some reference to statistics on who, I'm sure you can find something, somewhere on, on PubMed, or we have access to a lot of these databases at CUNY, or even just go onto the CDC's website and look at flu statistics for the previous year, and they have statistics on, how many cases they had, different areas, whether or not people with insurance, who is getting flu shots, who isn't. In other words, give us some references, something that says to me that you researched it a little bit. So is this something that is like a capstone? No, it's a simple little project, right? Don't turn it into a capstone. At the same time, take it as an opportunity to actually do some real statistics, take a real database, real statistics, and evaluate it. You may use any of these databases that I've put here. There's stuff, let me show you here. You open this up. She actually knows this person. Okay, here, this is just an example of a really good one. A educational intervention, geriatric, non-geriatric healthcare providers, cognitive functions, and here's the background, here's the objectives, here's a picture, here's a picture, yeah. Here's methods, the methods that she was using, And this is very elaborate. I wouldn't expect this from everybody, right? Here's the results that she got. She gave us a graphs. She gave us comparisons, the distribution of males and females in the population she was examining, the age distribution. She gave us a histogram, shows us the age distribution, right? It's skewed towards older people, right? And so on and so forth. The distribution.
The project, or is this the?
This is the project.
Paper?
This is the project.
I mean,
This is a project. She went, this is more than you need to do.
right.
Right. Remember, I said 4 to 8 pages, 10 at the most, and I'm already past 10. And then at the end, this is the discussion. She printed it upside down. This is a discussion, box plots comparing delirium in older hospitalized patients, pre to post. And this is pre-test score, post-test score, and you can compare the delirium. And this is some sort of numerical variable for the delirium, pre and post-test score. It's like a numerical score. So she used these box plots to describe the distribution of the data. And you can see that the median for this group is higher than the median for this group, and similarly here, and so on and so forth. And then a discussion. It's upside. The reason why it's upside down here is because, well, kind of upside down. The reason is that the way we did this, she did this for a brick and mortar course. And in the brick and mortar course, what we had people do is print these out. And then we brought in like a dozen of these foam core boards, like you do a science project, and some tacks, some thumbtacks. And we had them take these and lay them out on there so it looked like a poster. So when this was laid out on the board, it looked very much like the one that we saw online, right? So conceptualize it that way. You're doing a poster, but you're not going to have the opportunity to put it onto a foam core and lay it out and then spend 5 minutes summarizing your research, because that's what had happened. You go to these poster sessions, you walk down a row of posters, and you'll suddenly see, oh man, look, this guy's doing something I'm really interested in. This is right up my alley. You'll stop. He'll be standing there, or she'll be standing there, and you can stop and discuss their research with them, and they can go into more depth. And the idea here was when we did this brick and mortar, then every person in the class had 5 minutes, 3 to 5 minutes, to stand, put their poster together, stand in front of it, and do a presentation to the whole group, right? And the next person, and then as the person was done, they would take their stuff off, the next person, and we'd be moving down the road as other people were putting their stuff on there. So if it conceptualized that way, obviously, if you want to come in on the last day and do this, we can do it online. But for the most part, because we're doing this online, you're just going to submit this as a report like this. And again, this is over the top for in terms of requirements of this.
So
I'm sure.
You want slides instead of actual.
Yeah, you could do it as slides, like PowerPoints, like this. Yeah, kind of like, she kind of did it as a combination. I mean, these are kind of like slides, but at the same time, you could paste them together into a poster. But put your head around kind of like if I was doing this as a poster, what it would look like.
Will we be able to see other people's?
That's a good question. The answer would have been yes if a brick and mortar we were doing them together. But the answer is, not likely. Not likely. However, what I can do is I can set up a place on the discussions board where you can upload your presentation and have other students comment on it, which would be a nice thing because I'll also look at it and I may give you some pointers and say, holy crap, you're doing the wrong test, so that you don't wind up, submitting a paper where you're doing it completely off base, right? Which is a good thing, right? So that you get some feedback on it. So yes, I will make something on Blackboard where you can upload it to the discussions forum, and then other students and myself can comment on it, make suggestions, and so on and so forth. Okay, so that's that. How do you think? Would you rather do that than an exam?
I want to do this so I can get.
You want to do it because you already have ideas where you want to go with this.
Yeah, I feel like you'll help me put into practice.
Okay. So I need to take a 5-minute break to talk to somebody that's here and to also get my voice back a little bit. Okay, so let's take a short break.
This conference will now be recorded.
Okay, guys, I believe we're back and we're recording again, and you can hear my voice again and see my screen. So that's basically where we stand on the project. Don't think it has to be this elaborate. It doesn't have to be this elaborate. Okay, so now as far as the exam is concerned, let's talk about the exam. We didn't get to much of a review today, so what I'm going to do is I'm going to sometime between in the next week or so, I'll do like a Q&A session online. So if you email me, and again, make sure whenever you email me, BIOS610 has to be in the subject line. So I recognize it, I grab it, and I respond to it. Otherwise, it's hit and miss because I get so many emails and my spam filter does weird things. Okay, so again, this doesn't, your report, this is just like, like a best case kind of thing. Your report doesn't have to look like that. Doesn't have to be anywhere near as elaborate as that. And if you really feel uncomfortable doing that, you can always just take the exam on those couple of topics at the end. As far as the exam is concerned, the exam will cover everything that we did since the first exam, which includes, the first exam we did confidence intervals for numerical variables, for proportions, and so on and so forth. And then we got into, after the first exam, we got into the central limit theorem, that whole thing about standard error and so on and so forth, and confidence intervals calculated using the t-score and so on. So it might be a little bit of that, but there'll definitely be something on it. There'll be some kind of t-test, right? Maybe a single sample t-test, maybe some other. Yes?
Can you calculate unequal, like how do you?
Oh, okay. Yeah, let's talk about that. Well, first of all, number one, in class, a lot of times I'll show you something in class which is very elaborate and difficult, but then I don't necessarily expect you're ever going to be doing that in real life. So for instance, when we were talking about the t-test, let me go to weekly materials here and let's go back to the t-test. Single sample, two sample t-test probably in here. And let's see if the data files are in here. Yeah, here we go. T-test variations. Now you may have remembered that I had told you that if you have two samples, right, you want to compare the means of the two samples. So sample A, population A, population B. So your null hypothesis, you would set up a null and alternative hypothesis. I will expect you to do that on the exam. So in this case, since it's two samples, mu for group A is equal to mu for group B. The alternative hypothesis is mu for group A is not equal to mu for group B. That's a double-sided null and alternative hypothesis. We talked very briefly about single-sided hypothesis. I'm not going to have you do anything with single-sided hypothesis for the exam, so you don't have to worry about that. So I might ask you, what are the assumptions that you make when you do a t-test? For instance, that the sample is independent, that the sample is random, that the original population is approximately normal, right? So these might be some of the assumptions. If you go back on the PowerPoints, you will see some of the assumptions, right? So I might ask you about that. But then let's say I ask you to actually do this. You probably do something like this, lay out the null alternative hypothesis. Well, then you would make a judgment. Are the standard deviations equal or unequal for this particular analysis? And if you're doing it manually, I mentioned that if the standard deviation of group A, sample from group A is equal to standard deviation is less than twice or double, less than one half or double what the standard deviation for the other group is, then just assume them to be equal, which means that you would calculate a pooled standard deviation, right? This is standard deviation group 1, standard deviation group 2. This is sample sizes, okay? Calculate a pool, and then use it in this formula to find your t-score. And your degrees of freedom are the sum of the two sample sizes minus 2. You go to a t-table, determine the critical value of t you need to exceed in order to reject the null hypothesis, right? And then calculate your t for your analysis, which is the difference between the two means of the two samples over the standard error. And this is really this is really disguised here but that's the standard error using the pooled standard deviation. Well, what about if they're not equal? Then you would use this formula here. If one standard deviation was 10 and the other was 30, more than double the other, you would use this formula instead, and then this ridiculous formula to calculate degrees of freedom. Now, in real life, I'm not going to ask you, I might ask you to do a single sample t-test, but I'm probably not going to ask you to do this, right? It's just going to take too much time. So what I might ask you to do is I might give you a version of this file for SPSS and ask you to do a t-test in SPSS. And SPSS, when SPSS analyzes a data file, I'm going to grab one here, 2 sample t-test. Save link. I'm going to drop this up here. I'm going to say OK. I don't think I said OK. I think I clicked something else. Desktop. I'm going to say save. Good. Okay, and then go to SPSS again. I'm going to open that file. Open. Data. And I'm going to go over here and say, okay, where did I put it? 2 samples. Okay, I'm going to open that up. Okay, so I just opened this up. There's 2 variables. One is values and one is gender. The values is whatever it happens to be. What do the numbers look like? I'm going to put down that that's test score, quiz scores. Whatever it happens to be. So those are the quiz scores, and this is the sex or gender. So I go back here, I'm going to say turn on the value labels, and you can see that these are population of males and females. These are their various scores, and I want to find out whether now I have gender in a numerical variable. It happens to be dichotomous. So I'm going to do a t-test. I'm going to look to see if the average score for females is different than the average score for males. So I go to analyze. Now I'm going to go down here to compare means because I'm comparing means of the 2 groups. Compare means, independent samples t-test, because there are 2 samples. One sample of females, sample of males. They're not the same person sampled twice, like a paired sample. And it's not a 1 sample test because there's 2 samples here. So the quiz scores, which I spelled wrong despite everything else, and gender goes in here. Okay, now grouping variable. Now I have to tell it what those 2 numbers mean. Remember the coding? Okay, I forgot already. It is 1 and 2. 1 and 2. What's that?
The coding is smoker?
Oh no, I'm talking male and female, a different data set. Okay, you can't, is that too small to see? Is that what it is?
No, it's fine.
Okay, so I'm going to define the gender as 1 and 2 for male and female. Continue and say okay. So it does a t-test for me. And it tells me that the average score for females is 10. The average score for males is 7.56. The standard deviation for females is 2.7 and for males 1.9. Should I assume equal variances here? Remember I said it's got, as long as it's not double, one not double the other. Is one double the other? Almost, but not quite, right? So I would assume equal variances, right? I would not say that they're different variants. So if I go down here, what SPSS does is it doesn't even care about that. It says to itself, I'm going to calculate it 2 ways. I'm going to calculate it assuming equal variances and not assuming equal variances. So if you look at the t-test actually begins, you see there's a drop line here from the P straight down, right? To the right of the that line, that skinny line, is the actual t-test. To the left of it is a test for equality of variances. One way I could look at this is to just say, hey, listen, one's not double the other, so I'm going to stick with the top line, equal variances assumed. Or if one was double the other, I would sticking with the bottom line. But this test actually statistically calculates which one you should use. It's called Levine's test for the equality of variances. You use it just like we did everything else. The null hypothesis is that the variances are equal. There's no difference between the variance. So the null is, the fallback is equal variances assumed. If the probability of getting this big a difference between the variance is less than 5%, in other words, the significance less than 5% here for the equality of variances. If this is less than 5%, I reject that idea and use the bottom line. So what is it? Is it less than 5%? No, it's 24.5%, 0.245. So I stick with the top line because this is not less than 5%. So the top line tells me that the t-score is 2.184 with 16 degrees of freedom. Now, I normally, if I just calculated that by hand, I'd have to go to the t-table to look up what the critical value of t is for 16 degrees of freedom. And I'm just going to say it's probably something like 2.1. Okay, so if its critical value is 2.1, my t-value, the difference between my two means, gives me a t-value greater than 2.1, so I can reject my null hypothesis because they're so far apart. SPSS doesn't bother comparing it to the critical value of t. It just gives you the probability that you would get this extreme a value if the null hypothesis were true. So there's less than 5% chance that you'd get this big a t-score if the null hypothesis was true. So since there's less than 5% chance of the null hypothesis being true, you reject the null hypothesis and accept the alternative hypothesis. Had this been 8%, 0.08, we would have failed to reject the null hypothesis. Okay? Makes sense?
Did you repeat the last part?
If this had been bigger than 5%, if it had been like 8% for significance two-tailed, that's the p-value. If the p-value, in other words, a significant two-tailed significant, also known as the p-value, if that was bigger than 5%, we would have failed to reject the null hypothesis. Okay, I hate to say this, but it's 9:50, and the lights will be out in 10 minutes. Like I said, I will schedule some sort of Q&A online for the. We're not going to meet again till December 5th, right? Where we have Thanksgiving, right? You can come in here. I won't be here. The school may not be open. The lights will be out, but you can come in if you want. But I don't suggest it. Okay, I suggest you stay home, have a nice dinner, deal with some tryptophans, and have a nap afterwards. Make the guys wash the dishes, right? It's only fair. Actually, I do a lot of the cooking. I like cooking. So at any rate, like I said, I'll schedule some kind of Q&A. I'll also put something into the discussion boards where you can post questions, or you can email me questions. And I will, if whatever time I schedule the Q&A, if you can't make it, if you email me questions to address then, or post them on the area where I put it on the discussions forum, I will make sure to cover them when I do it and record it so that you can go back, and if you couldn't make it live, then you'll see the answers. Yes.
Is there a review sheet in the previous classes?
That's a good question. I might be able to dig up a sample exam. But between me and you, let me think about this for a second. You're going to get 2 SATs at the same exam.
Oh, no, like something with the proper formulas and stuff.
Oh, that's a good question.
Because when I go online and search things, I get like financial formulas.
Yeah, you don't get biostatistics. Yeah.
It's hard to figure out which t-test to use and stuff.
Well, for the most part, you're going to be using SPSS to solve these. So if you don't have it,
but a lot of people don't have SPSS.
they're supposed to have it as part of this course. I know you were supposed to get it for free. I can't fix that, but it's only $35, right? And you really should. It's a tool. You want to put on your resume, I know how to use SPSS. You want to be able to be functional with it because it's something that may come in handy in the future, right?
So
when I was in junior high school, they wouldn't. The wood shop filled up. They made me take typing. I was miserable. I hated it. I hated it. That was like this. I hated it. But in the early 80s, I looked down one day and said, holy crap, I'm so glad I know how to touch type. right? Because word processors and I still have friends to this day, my age, 2 fingers, right?
And people younger.
I can't tell you, I can go find wood shop anywhere now, but I would never have I would never have the patience to learn the way they made me learn then. I had one of these big steel typewriters with keys on it with no letters on them. And you had to do exercises. ASDF, JKL, colon, back and forth and do X and get, so on and so forth, and type on it and hand it in and stuff like that. They had to time you and stuff like that. So they were pretty rigorous about it. And let me tell you, I hated every minute of it. I really wanted to take woodshop, but this was far more valuable to me than woodshop was. I still learned how to cut a piece of wood anyway on my own, but I would never learn how to type properly without taking that course. There was there was like, there were programs, Mavis Beacon, right? There were like these programs. You don't see them around anymore because I guess so many kids they spend all their time on the computers anyway, so they know how to type. Right, they know how to type. That's not even an issue. So guys, I'm gonna log off here so you guys can get some sleep online and we can get out of before the lights go out. So have a great holiday. Enjoy your Thanksgiving. Have a safe and healthy one too. And I'll see you guys when we get back. Keep an eye on Blackboard for information about the exam. The exam will be posted sometime around the middle of next week, hopefully before Thanksgiving for sure. And if you have questions, concerns, I'll have a Q&A session online at some point in the interim. And if you have any questions, Blackboard or email me.